Remainder theorem and division. Okay, we're going to need this skill because we've been talking about polynomials. We've been talking about how to write them. We've been talking about how to graph them. Everything is dealing with these different polynomial functions. And the remainder theorem here is going to help us determine which zeros are actually zeros of a function. So the remainder theorem basically helps us determine whether or not a value is indeed an actual zero of the function. In other words, an x-intercept. Okay. Later on in the lesson, we're going to do some long division, some phase division with polynomials. That's going to actually help us do our last lesson of the unit, which is a beast. Okay. So here we go. What is remainder theorem? If a polynomial f of x is divided by x minus c, the remainder is r equals f of c. Now this might look a little bit weird. You're like, okay, what all does this mean? Remember, c comes from this. X minus c. C can be any type of number, such as x minus 2. Okay? We've seen that. That's like a factor. You know, so that if we set it equal to 0, x equals what? 2. 2 would represent a 0. Okay? 2 is that c that you would put here. Then we have f of 2. What does f of 2 mean? For every x, you're going to put a 2 into the function and find the value. Whatever this is, whatever you get when you plug that c into the function gives you your remainder. Okay? That is remainder theorem. If the remainder equals 0, am I jumping ahead? I think I am. I'm going to hold back. I'm jumping ahead. So again, this means that you need to evaluate the polynomial function f of x for x equals c. Figure out what c is, plug it into the function, and whatever you get is the remainder. Okay, whatever you get is the remainder. And then we're going to look at this example right here. So again, to determine what your remainder is, you need to figure out what c is going to be, and you get that from the factor. And you're going to plug it in for every x that you see into the function and evaluate.
So the c in this case would be -1.
Exactly. So in this case, it's going to be not -1, but +1, because it's like you set it equal to 0 and then you solve it. So c is going to be 1. So that means that I'm going to do f of 1 in this function, and I'm going to evaluate it. This will give me my remainder. For this polynomial. Order of operations. What's 1 to the 4th power? Times 4. What's 1 to the 3rd power? Times 21. 1 to the 2nd power? Times 25. What's -5 times 1? -5 plus 3. I'm like, wait a minute. I asked y'all what the power was, then multiply. Y'all came out with ease. What I asked you was 5 times 1? What? Okay. And then you just simplify, okay? 4 plus 21 is 25. Plus, I mean, to be honest, it's however you see how to add this. Okay, this is how I see to add it. This will give me 48. Part of it. So the remainder of this polynomial function is 48. The remainder of this function is 48. And again, we get that by figuring out what c is and then plugging it in. Okay, c is what you get when you set that little, whatever it's asking you to divide by, equal to 0, and you solve. Okay? Now, why is this important? I'll tell you why. Because if the remainder is 0, that means that x minus c is a factor. If it's a factor, that means it's an x-intercept, which leads to graphing your polynomials and so on and so forth. That's how it all ties in. Okay? So get this down. A polynomial f of x has a factor x minus c if and only if f of c equals 0. In other words, the remainder equals 0. Then x minus c is a factor. This is known as factor theorem. So if I go back to that very first example, was x minus 1 a factor? No. What was its remainder? 48. X minus 1 is not a factor, which lets us know that 1 is not a 0 on this polynomial. If the remainder had equaled 0, then yes, it would be a factor, which means that that c value would be a 0 on our polynomial function. Okay? Let's look at this one together, but you don't have to write it down. Okay? I want to find the remainder for this particular function. What's going to be the c that I'm going to plug in? Negative 3. The opposite. So then we'll have 4 times negative 3 to the 4th power plus 21, negative 3 to the 3rd power, so on and so forth. Y'all know this is the same function from before, right? So now let's see if x plus 3 is a factor. Let's see if negative 3 is a 0 for this polynomial. Negative 3 to the 4th power, does anyone know it? That's the 3rd. It's 81. What's negative 3 to the 3rd power? Negative 27. What's negative 3 to the 2nd power?
9.
What's negative 5 times negative 3? And plus 3. All right, let's multiply this out some. Let's see, 81 times 4, that is 324. Then this is going to be a minus, huh? That's why I'm doing it out this long. We've got 576, 567, I mean. Let's eat. But 25 times 9, y'all should be able to do 225. Think about quarters, 9 quarters, how much money you have. That's one way to think about it. It's 18. That's why we're doing this one together, because it's a bigger number. Since we're not going to give you any calculators for this test, the numbers are going to be something that you can fairly work out, or old school multiplication there. Okay? To make this a little bit easier on myself, I'm going to add these together. So that's 3, 4, and 2. Let's see. I'm going to add my positive numbers together, so that's going to give me 7, 6, 5. So what's my remainder? 0. So what does that tell me? X plus 3 is a factor, and then x equals negative 3 is a 0. That's what it tells me. Okay? Good stuff. Questions on remainder theorem? So main things to take away. Make sure that everyone understands. R is the value of f of c. Well, just make sure you have this somewhere in your notes. Remember, R stands for what? And we get that by taking the c value and plugging it into the function. If R equals 0, then x minus c is a factor. Remember, the remainder is 0. That means that what we were asked to divide by is indeed a factor, which means that c value is indeed a 0. Which is what the third point is. If R equals 0, then c is an x-intercept of the graph. It's a 0. It's a root. It's a solution. And if R equals 0, then we know that x equals c is a solution when you set the polynomial function equal to 0. Okay, that's what the remainder theorem basically gives you. By plugging in that c value, finding the remainder, you can determine all these different things about a particular polynomial function. So continuing forward, we're going to talk about long division and synthetic division, the concept that you guys would have done back in Algebra 2. Okay? We need this to prepare for our final lesson in this particular unit, which actually helps us go from the actual long polynomial function to like the 6th degree to actually finding the zeros. So we definitely need this skill here. Okay? And so this pretty much is review. We're not going to do every problem in this foldable. You guys can use those for practice on your own. But let's review long division. Okay? Long division is the one that you have the little radican symbol. Okay? And then what you do is you put your 12x to the second power plus 8x minus 15 underneath your division bar. And that 2x plus 3, that is your divisor. Okay? So 2x plus 3 is your divisor. 12x squared plus 8x minus 15 is called your dividend. And the answer that you get when you actually divide is called your quotient. So what's on top of the division bar, that's called your quotient. And so when you're dividing using long division, you ask yourself, based off of what number is in the front, this which is a 2x times what gives me 12x squared? A 6x. Now for me, because I'm all about, lining things up, as you guys remember from when we were, expanding, I lined up my x squares, my x cubes, and stuff like that. Of course, I'm going to put a 6x over the 8x and line up, make it look nice and pretty. But you ask yourself, what times this first term, which is a 2x, is going to give me 12x squared, the first thing in my dividend, and that is 6x. So then you take that 6x and you multiply it to the entire divisor, not just the 2x, but to the 3 as well. What's 6x times 2x? And it should be the exact same thing as what's underneath it. What's 6x times 3?
18.
So you have plus 18x. Now, if you recall from doing old school long division, technically at this point you're going to need to subtract what you see in the red. What I like to do is basically I'm going to change the signs of every term of what I just got. Because when you subtract, you're subtracting that entire thing, which changes the signs of both terms. Okay? When that happens, your 12x squares are going to cancel out, and you have 8x minus 18x, which is a negative 10x. And don't forget, we are dividing, so you bring down the next term. Is this coming back to you guys?
Yes.
Then you repeat. What times 2x gives me a negative 10x? A negative 5. And so we repeat. We're going to multiply that negative 5 to the entire divisor. So that gives us a negative 10x minus 15. And we can't forget to do what? Change the signs, because we need to subtract that entire blue line. So when I change the signs, this turns into a plus. This turns into a plus, and what do you see? Everything cancels out, and our remainder is 0. So our answer is 6x minus 5. Your answer is the quotient that you get when you divide. But since my remainder is 0, I also know what fact? 2x plus 3 is a factor, and if I solve that out, set it equal to 0, I have one of my x-intercepts. Okay?
What do you do with 3?
What's 3? Oh, 3 is just there when you multiply through to the divisor. But when it comes to determining what was a part of our quotient, we only use the very first. Only the very first term in the divisor. Okay? Let's look at number 2. Okay? Drawing my division bar, write down every term for my dividend, and my divisor goes on the outside. One quick note. If your dividend or your divisor is missing a term, say it's missing the x squared term or the x term, you need to put in a 0 placeholder. Otherwise, your entire thing is going to be off. So, we start again. X times what gives us a 2x to the third? A 2x squared. Okay? So then I take that red 2x squared and multiply by the entire divisor. 2x squared times x, 2x cubed. And 2x squared times a negative 4. At this point, we have to what? Change our signs. So this is going to become a negative 2x squared, and this is going to become a positive 8x squared. These should cancel. If you do it right, things should cancel out as you're dividing. What's x squared plus 8x squared? 9x squared. And we need to bring down our next term, which is a negative 31x. Repeat. X times what gives me a 9x squared? A 9x. Positive or negative? So plus 9x. And then we multiply. 9x times x? 9x squared. 9x times a negative 4? What do I need to do? Change the sign. So this becomes a, and this becomes a, these cancel. Negative 31x plus 36x is a 5x. Then I bring down the next term, which is a minus 20. One last time for the good time. X times what gives me 5x? 5. Then I multiply 5 times x is, and negative 4 times 5 is, and you can't forget to change your signs. So this becomes a negative, this becomes a positive. Everything cancels out, leaving me with a remainder of 0. So my answer is this 2x squared plus 9x plus 5. And I also know one little bit of piece of information. Since my remainder is 0, x minus 4 is a factor, so that means what is a 0? X equals 4. Very good. Now let's say you do have a remainder left over, okay? Because I'm pretty sure probably that's what 3 and 4 actually have, and we're not going to do 3 and 4. Whatever your remainder is, you add it, or if it's a minus, you subtract it from the quotient, and you write it as a fraction with your divisor. So this is basically what it should look like. Whatever your quotient is, you write it out, and then you'll plus, if it's positive, or subtract, if it's negative, your remainder all over your divisor. Okay, that's how you would write your final answer if there actually was a remainder. Okay? That's how you actually would write it. So, just to make sure everybody understands that, let's say the remainder was actually like a positive 1. So my answer would be 2x squared plus 9x plus 5, which is the quotient. Since this is a positive 1, I'm going to put a plus my remainder, which is 1, all over my divisor, which was x minus 4. I just made this up so you guys can see what it looks like when you have a remainder. And that's exactly how you write it. Your remainder divided by your divisor. And that's your answer. Sound good? Okay. Let's go to some things. That division can only be used if your divisor is a linear factor. A basic one, like this. X minus 2, x plus 3, x minus 5, x plus 1, x minus 6, x plus 3. But if it's 2x plus 3, you're going to have to use long division. Long division works every single time. Synthetic only works when it's simple like this. Okay? This is where you have the backwards L, your line. Inside your backwards L is going to be your C. What's my C here? 2. Remember that comes from the divisor. That equals 0. So. And then beside the L, I'm going to put the coefficients of my dividend. So that's 8, negative 13, and negative 6. Again, if you are missing a term, when you start at x squared, if you're missing the x term or you're missing the constant term, you've got to plug in a 0 placeholder. Don't throw everything off if you don't. And the first step of synthetic division is you bring down the first term. Always. You always bring down the first term. And then you multiply that number by the C, whatever's in that backwards L. What's 8 times 2? 16. Then you add, or subtract because of minus. What's negative 13 plus 16? Positive or negative? Positive 3. You repeat. You multiply that 3 by the C. What's 3 times 2? 6. What's negative 6 plus 6? 0. The number that's always last is always your remainder. And these two numbers that are to the left of that, I guess I know how to describe it. Whatever to the left of the remainder, that actually represents your quotient. And you always go 1 degree down from whatever you start with. So if you start with the x squared, your quotient will be 1 less power. So if I start with a square, this just becomes a regular x. And ax plus 3 is my quotient, is my answer when I divide these two. Okay? Questions? Look at the next one. What goes in my backwards L? And beside the backwards L go my coefficients, which are
5, 29, negative 40, 14.
I wasn't missing any terms, was I?
No.
And remember, anytime you miss a term, you need to plug in a 0. I'm going to go ahead and put in my remainder box because I know it always goes underneath the last term. Then the first thing I do, drop the first number. Multiply, so I get negative 35. Negative 6. Then I, negative 7 times negative 6 is, what does this become? Positive 2. Negative 7 times 2 is a negative 14. And again, I have a remainder of 0. 0 is my remainder. And since 0 is my remainder, that tells me that x plus 7 is a factor. It also tells me that what is a 0? X equals negative 7. And my quotient is going to be 5x to the second power minus 6x plus 2. And again, if there was a remainder, you would write it as remainder over divisor. Questions on synthetic or long division? We're going to practice some more on Friday with synthetic and long division, which is tomorrow. But that's how you use remainder theorem to determine if we have any zeros, any factors, and the synthetic division, which we're going to use for the next one.